So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, welcome to this problem solving video. So let us read the question. In this signal it is saying that a message signal M of t and it is band limited to frequency FM and it has power of PM. So suppose we have m of t. So it is saying that this particular m of t signal has maximum frequency component, which is fm, and it has power or mean square value, which is equal to pm. So now if you have to draw the spectrum of m of t, so you can draw a band limited signal which has maximum frequency as fm. So this will become minus fm, and this is mf versus f. So this is the general description of any general baseband signal. The shape does not matter, so I have made the shape of triangle. You could have made any shape. The purpose of that shape should be that it must occupy the frequencies from 0 to fm positive side, and obviously this m of t must have been a real signal because it is a message signal, so that is why its spectrum has to be even in nature. So this is the general description of a spectrum of any band limited signal. Now it is saying they calculate the power of the output signal. So first of all, let us see what is the output signal. So this signal m of t into cos omega naught t, and here it is cos omega naught t plus theta. Both these signals are getting multiplied. So let me denote this as x of t, and let me denote this output signal as y of t. So now first of all, let us calculate what will be this x of t. So this x of t is nothing but it is mt cos omega naught t into cos omega naught t plus theta. So you can write it as m of t by 2, and it will become 2 cos omega naught t into cos omega naught t plus theta. So this x of t can become mt by 2, so it will become cos a plus b plus cos a minus b. So this x of t signal can be written as mt by 2 cos of 2 omega naught t plus theta plus mt by 2 cos theta. So till now picture is very much clear. Now you know that if this m of t is band limited to minus fm to fm, so whenever you will multiply it with a high frequency carrier, which is 2 omega naught, so it will shift to a higher frequency. Now let us see what is given in the problem. In the problem, another information is given to us that this omega naught should be greater than 2 pi fm, or you can say that this f naught will be greater than fm. And the characteristic of the filter is given that it is an ideal band low pass filter, and whose cutoff frequency is fm and pass band gain is m. So these two informations are given. First information is given that this f naught is very much greater than fm, and also the characteristic of the filter is it is restricted from minus fm to fm, and its peak frequency should be 1. Its pass band gain should be 1. So now we have this x of t which is being passed through an ideal low pass filter, and we are expecting an output y of t, and this low pass filter has the characteristic of minus fm to fm. This is 1, and this will become h of f versus f. So let me draw the output. So what will be this output? Yt can become xt convolution ht, or in frequency domain it can become yf equal to x of f into h of f. So this is the output yf. Now this is your x of t, which is nothing but mt by 2 cos theta, which is mt by 2 cos theta plus mt by 2 cos 2 omega naught t plus theta. So we know that spectrum of m of t is occupying the spectrum from minus fm to fm. This is f, this is m of f. So what will be the spectrum of mt by 2 cos theta? All these parameters are constant, so spectrum does not change. So their peak values might change, but as far as frequency is concerned, it remains the same. And what will be the spectrum of this mt by 2 cos 2 omega naught t plus theta? So whenever you will draw its spectrum, the frequency will be shifted f2 f naught rightwards and to f naught leftwards. In the problem it is given that f naught is greater than fm, so obviously 2 f naught will also be greater than fm, and you can say that this 2 f naught minus fm is always going to be positive. So whenever I will shift this particular spectrum by 2 f naught, so this frequency reaches to 2 f naught minus fm and it reaches to fm. So this frequency becomes 2 f naught minus fm. The center frequency becomes 2 f naught and it becomes 2 f naught plus fm. Similarly on the left side also, it becomes minus 2 f naught minus 2 f naught minus fm minus 2 f naught plus fm. So let me draw the complete spectrum. So the spectrum of this x of t looks like this. It has one spectrum which is from minus fm to fm, and this spectrum is corresponding to the signal mt by 2 cos theta. Similarly, we have two another spectrums. This is centered at 2 f naught. This becomes 2 f naught minus fm, 2 f naught plus fm, and this becomes minus 2 f naught minus fm, and it becomes minus 2 f naught plus fm. So from here you can also see that if f naught is greater than fm, so you can also write it as 2 f naught should be greater than 2 fm, because I have multiplied 2 on both the sides. So you can also write 2 f naught minus fm should also be greater than fm. So this equation you can also write. So that is why the 2 f naught component will be here and fm component will be here. So this will be the situation right now. So from this f naught minus fm we gave the two conclusions. So f naught greater than fm basically provided us two conclusions. One conclusion, it provided that this 2 f naught minus fm will always be positive, and along with that 2 f naught minus fm will also be greater than fm. Now what is the and this particular spectrum is corresponding to mt by 2 cos 2 omega naught t plus theta, and this component is corresponding to mt by 2 cos 2 omega naught t plus theta. Now when it will be passed through an ideal low pass filter, so that ideal low pass filter will allow only frequencies from minus fm to fm, and it will multiply it with 1. So this is your hf, this is your x of f. So what will be y of f? So y of f will be the signal in the frequency domain minus fm to fm, which corresponds to mt by 2 cos theta in time domain. So if I have to write my yt, so I can write yt as mt by 2 cos theta. Now you could have directly calculated it from here also. So I have shown you the exact procedure. Now you can see that this is the filter and this signal has to be passed through it. So pass band gain is 1. So you can see that if the frequency of mt is fm and it has the frequency of 2 f naught, so this overall signal will have frequencies of 2 f naught plus minus fm. Now in the problem it is given that f naught is greater than fm, so you could have written 2 f naught is greater than 2 fm, and this 2 f naught minus fm will be greater than fm. So if this 2 f naught minus fm is greater than fm, so obviously this 2 f naught plus fm will also be greater than fm, because when fm is subtracted from 2 f naught, then only it is greater than fm. So if we'll add fm in this to f0, then also it will be greater than fm. So you can see that this complete component is not allowed by the filter, because the filter is passing only frequencies from minus fm to plus fm. Now let us consider the second component. So second component is mt by 2 cos theta, and we know that this cos theta is constant, divided by 2 is constant, and it has frequencies only of fm. So this m of t signal will be allowed by this h of f. So you could have directly written the output, which is m of t by 2 cos theta. So same output I have also derived for you with the help of frequency domain. So finally, the y of t that we got is cos theta by 2 into mt. So this is the constant. We know that if you will calculate the mean square value of this, which means the power of the output, so it comes out to be, if any constant is multiplied with any message signal, so we can directly square the constant. So it becomes this square into mean square value of mt. So you can write py equal to cos square theta by 4, and this symbol is nothing but power of the message signal. So power of the output can be written as pm by 4 into cos square theta. So this should be the right answer. Now let us check the options given. So one option is also here given, which is pm by 4 cos square theta. So this should be our correct answer. Now let us proceed on to the next question. Now let us consider what is saying in this question. In this question, a message signal is given, which is having some sin 80 by pi t format. So basically this message signal is 2 sin 2 pi t upon t. And another signal s of t is given as, which might be behaving as a carrier, which is cos 200 pi t. And another signal n of t, which can behave like a noise, so it is sin 100 990 pi by t. So here it is mentioned that it is a low pass filter, and we are asked about the output y. The characteristics of low pass filter is not mentioned here, so I am mentioning it that it has cutoff frequency of 1 Hz and it has pass band gain of 1. So this low pass filter might look something like this. This is h of f versus f. It will be 1 minus 1 1. So this is the characteristic of the low pass filter. So we have to obtain the particular output yt in time domain also. So let me give different names here. Let me call this as x1t, this output as x2t, and this as x3t, and finally we have to calculate yt. So let us start from here. We know that this x1t will become mt into st. So what is mt given in the question? Mt is nothing but 2 sin 2 pi t upon t into cos 200 pi t. So we can apply 2 sin a cos b. So it becomes x1t equal to sin a plus b plus sin a minus b upon t upon t. So this is the x1t. Now what will be x2t? x2t is nothing but x1t plus some noise, which is n of t. So this x2t becomes sin 202 pi t upon t minus sin 198 pi t upon t plus sin 199 pi t upon t. And what will be x3t? x3t equal to x2t into cos 200 pi t. So this x3t becomes sin 202 pi t upon t minus sine 198 pi t upon t plus sine 199 pi t upon t, and it is multiplied with cos 200 pi t. So you can write it as sine 202 pi t into cos 200 pi t upon t minus sine 198 pi t into cos 200 pi t upon t plus sine 199 pi t cos 200 pi t upon t. So we can multiply with 2 and divide by 2 in each expression, so that we can again apply the formula of 2 sin A cos B. So we can multiply this 2 by 2 by 2. So I will deal one by one expression. So first of all, let me deal this. Let me give the names. Let me call this expression as 1, this expression as 2, and this expression as 3. So this x3t becomes equal to sine 202 pi t into cos 200 pi t upon t. So this 2 sin A cos B becomes sin A plus B plus sin A minus B. This is divided by 2t. This is also divided by 2t. So this is the first expression. This will not be x3t, rather it will be the first expression that we dealt with. The second expression that we had was, it was sine 198 pi t into cos 200 pi t upon 2t into 2. So it becomes sine 398 pi t minus sine 2 pi t. It is divided by 2t. It is also divided by 2t. Third expression will be 2 sine 199 pi t into cos 200 pi t upon 2t. So it will become sine A plus B sine 399 pi t upon 2t minus sine pi t upon 2t. So finally you can write your x3t which becomes sine 402 pi t upon 2t plus sine 2 pi t upon 2t minus sine 398 pi t upon 2t plus sine 2 pi t upon 2t plus sine 399 pi t upon 2t minus sine pi t upon 2t. So this is the picture till x3t. Now we can rearrange x of t a little bit. So it can be written as x of t equal to sine 402 pi t upon 2t minus sine 398 pi t upon 2t plus sine 399 pi t upon 2t plus can be written as 2 sine 2 pi t upon 2t, which means we have added this and this, minus sine pi t upon 2t. So Now this x of 3t is passed through a low pass filter, and we have to generate output yt, and this low pass filter will have frequencies from -1 to 1 Hz, and this is HF. So this filter can also be drawn in omega domain, so we can draw it like this. It can become -2 pi say 2 pi f h omega. So now our x3t has now overall 5 components, 1 2 3 4 5. So we will pass one by one with the filter. So the first signal is sine 402 pi t upon 2t. So the spectrum of this particular signal will become -402 pi to 402 pi in omega domain, and suppose this signal is p1t. So this p1 omega becomes pi by 2, because we have to multiply it here pi and we have to divide it by pi, so that we can make this sine 80 by pi t format. Now in the frequency domain it has to pass through a filter which is from -2 pi to 2 pi. This is your omega h omega. So whenever you will multiply these two signals, so the output of this particular signal becomes -2 pi to 2 pi, and this peak value remains pi by 2. So what will be its inverse Fourier transform? You know that it will be sine 80 by pi t. So we can write it as pi by 2 sine, instead of a we will write 2 pi upon pi t. So pi gets cancelled out, and we get y1t as sine 2 pi t upon 2t. So with respect to p1t, the output is coming out to be sine 2 pi t upon 2t. Now let us see what is p2t. So the second signal, which I am denoting it as p2t, is nothing but sine 398 pi t upon 2t. So we also know that its spectrum will become p2 omega versus omega. This peak value will become 1, and it will become -398 pi to 398 pi. So since we have to convert it in sine 80 by pi t format, so we will multiply it with pi and we will divide it by pi. So it becomes sine 80 by pi t. So this pi by 2 will be adjusted here. Now we have to pass it through a filter whose frequencies are present from -2 pi to 2 pi in omega domain, and this peak value will become 1. So whenever you will multiply these two signals, the output comes out to be from -2 pi to 2 pi, it will be omega, and this output becomes pi by 2. So you can write it as y2 omega. So what will be its inverse Fourier transform y2t? We know that this will act as a, so you can write it as sine 80 by pi t. If it would have been sine 80 by pi t, then the magnitude would have been 1, but magnitude here is pi by 2, so we must balance it with pi by 2. So this y2t again becomes sine 2 pi t upon 2t. So second expression's output is also sine 2 pi t upon 2t. Let us consider the third pulse, which is sine 399 pi t upon 2t. So you can also write it as pi by 2 sine 399 pi t upon pi t. So you can draw its spectrum, and the spectrum in the omega domain is coming out to be p2 omega 1, and it will become -399 pi to 399 pi. Again you have to multiply it with, this peak value will become pi by 2. Again you have to multiply it with a filter having frequency response from -2 pi to 2 pi. This is h omega versus omega. So again the output becomes y2 omega, which is from minus 2 pi to 2 pi. The peak value becomes pi by 2, and this becomes your y3 omega. So what will be this y3t? The inverse Fourier transform will again become, this will act as 2 pi, and this will be 1 into pi by 2. So it becomes pi by 2 sine 80 upon pi t. Again pi t gets cancelled out. So this y3t becomes sine 2 pi t upon 2t. So for the first three pulses or the first three components, the output is the same, which is sine 2 pi t by 2t. Now let us see the fourth component. So the fourth component in itself is sine 2 pi t upon t. So this can be written as sine 2 pi t upon pi t. So the spectrum can be drawn from minus 2 pi to 2 pi. This peak value will be 1, and it is P4 omega versus omega. Now you have to pass it through the filter, which has spectrum from minus 2 pi to 2 pi, h omega, pass band gain as 1. So if you will multiply these two, so it becomes minus 2 pi to 2 pi. This peak value is 1. It becomes y4 omega versus omega. So what will be its inverse Fourier transform? It becomes pi sine 80 upon pi t, because this term can be considered as a, and here the scaling factor is pi, so that is why we have multiplied it with pi. So y4t from here becomes sine 2 pi t upon pi t. And what is the fifth component? The fifth component p5t, which is equal to sine pi t upon 2t. So this can also be written as pi by 2 sine pi t upon pi t. So it becomes sine 80 by pi t format. So this p5 omega versus omega becomes spectrum from minus pi to pi, and this peak value becomes pi by 2. Now it has to pass through a filter which has frequency response from minus 2 pi say plus 2 pi. It will become omega. This is h omega, and the input is 1. So whenever you will multiply these two signals, it will become from minus pi to pi, and this peak value becomes pi by 2. So this is your output y5 omega. So if you will calculate its inverse Fourier transform, it comes out to be, this expression will become a, and this is your 1 into pi by 2. So it becomes pi by 2 sine 80 by pi t, or this y5t can be written as sine pi t upon 2t. So the overall output becomes y1t plus y2t minus y3t plus y4t minus y5t. So this can be written as sine 2 pi t upon 2t plus sine 2 pi t upon 2t minus sine 2 pi t upon 2t plus sine 2 pi t upon t minus sine pi t by 2t. Here it will be sine 2 pi t by pi t, because this pi will get cancelled out. So this is the output. So in this output you can see that these two components will get cancelled out, and it becomes yt equal to sine 2 pi t upon 2t plus sine 2 pi t upon t minus sine pi t upon 2t. So this yt can be written as, you can multiply it with 2 in the denominator as well as numerator. So it becomes 3 sine 2 pi t upon 2t minus sine pi t upon 2t. So this will be the output. Now this can also be written as sine 2 pi t upon t plus sine 2 pi t upon 2t minus sine pi t upon 2t. So here you can apply the sine c minus sine d formula. So what is the formula of sine c minus sine d? It will become 1 by 2t, I am taking it as common, so it will become 2 cos c plus d by 2 into sine c minus d by 2. So this yt becomes equal to sine 2 pi t upon t plus cos 1.5 pi t into cos 0.5 pi t divided by t. So this should be the final answer. So let us check which one of the options is correct. So from observation you can see that this C option is exactly matching. So this question is very good conceptually, and you have a clear idea of Fourier transform, inverse Fourier transform, filters and all. So then only you can obtain up to this correct result. Now let's move on to the next problem. In this problem it is saying that a 100 megahertz carrier of 1 volt amplitude and 1 megahertz modulating signal of 1 volt amplitude are fed to a balanced modulator. So we know that balanced modulator is nothing but a DSP-SC modulator, or basically a product modulator. So this is your product modulator. Now the output of this modulator is passed through an ideal high pass filter, and the cutoff frequency of the ideal high pass filter is given as 100 megahertz. Now the output of this filter is added with another 100 megahertz signal of 1 volt amplitude, and it is 90-degree phase shifted. So it is 90-degree phase shifted as shown. Now we have to ask the envelope of the resultant signal, and the envelope we have to calculate. So first thing which you should understand, that whenever such type of questions arises, so you must deal such type of questions in general form, and then later on you should put the value. So first of all we are given with 100 megahertz carrier. So this is your FC, and amplitude of the carrier is given as 1 volt. So I'm considering this signal as a general signal is AC cos 2 pi FCT. I will put the value of AC as 1 because it is 1. So we will write it as 2 pi FCT. Now this is your carrier signal. Now modulating signal is also given in the problem, and the frequency of the modulating signal is given as 1 megahertz, and amplitude of the modulating signal is given as 1 volt. So the modulating signal is also sinusoidal, and we will consider it as 2 pi cos 2 FMT. So I will also put the value of AM as 1 here. So finally we will get M of T as cos 2 pi FMT. So till now we have got two values. The carrier I considered as cos 2 pi FCT, and the message signal I considered as cos 2 pi FMT. So this is the carrier and message signal. Now both these signals are being multiplied, then it is passed through a 100 megahertz high pass filter. So first of all this C of t and this M of t is being multiplied, and then it is passed through an ideal high pass filter. So this is your ideal high pass filter. Now the cutoff frequency of this ideal high pass filter is given as 100 megahertz. So this frequency is 100 megahertz. So you can also draw the frequency response of this ideal high pass filter. So it will become HF versus F. It will become 100 megahertz and it will remain minus 100 megahertz. Pass band gain we can consider it as 1. So let me consider this output as x1t, this output as x2t. Now this output is added with, you can see from here that we are adding another signal which is having 100 megahertz magnitude and its amplitude is 1 volt and it is 90-degree phase shifted. Now you should understand if it is shifting it by 90-degree, so we can also shift it by plus 90-degree as well as we can also shift it by minus 90-degree. Now whenever in the problem it is not mentioned that whether we should shift it by plus 90-degree or minus 90-degree, we should always consider the shifting by minus 90-degree because we have only Hilbert transformer to provide this particular phase shift, and Hilbert transformer always provides the minus 90-degree phase shift. So this is the key point in this particular question, which you must understand that whenever in the question it is not mentioned that whether we should use plus 90-degree phase shift or minus 90-degree phase shift, you should always consider the phase shift of minus 90-degree because the phase shift will be provided by any practical device, and we have only one practical device which is Hilbert transformer to provide the minus 90-degree phase shift. So here we will have another signal which has amplitude as 1 volt and phase shift as minus 90-degree. So you have already considered your C of t as cos 2 pi fct and your M of t as cos 2 pi fmt. So this signal is also has 1 volt, frequency is same as 100 megahertz, but it has phase shift of 90-degree which we considered as minus 90-degree. So the general expression of this particular signal, let me call this signal as C dash t, it will become AC dash cos 2 pi fc dash t minus 90-degree. So AC dash is same as 1 volt. This FC dash is again 100 megahertz, so I will call it as FC because FC we have already considered as 100 megahertz minus 90-degree. So this signal C dash t comes out to be cos 2 pi fct minus 90-degree, or you can write C dash t as sine 2 pi fct. And finally this is your output yt, and we are interested in the envelope of yt. So this is the question. So only this point was a little bit tricky, which you should understand that whenever it is using the same amplitude, same frequency, but the phase shift is minus 90-degree. So if initially I have considered it as AC cos 2 pi fct, so here I should consider it as AC cos 2 pi fct minus 90-degree. So now let us try to solve the question. So we know that this x of t will become M of t into C of t. So it becomes cos 2 pi fct into cos 2 pi fmt, or it can be written as 1 by 2 cos 2 pi fc plus fm into t plus 1 by 2 cos 2 pi fc minus fm into t. So I can write it as 1 by 2 cos 2 pi fc plus fm into t plus 1 by 2 cos 2 pi fc minus fm into t. So we know that this fc plus fm will become 101 megahertz and this fc minus fm will become 99 megahertz. Now it is being passed through the high pass filter. So you know that high pass filter will allow only those components which are above 100 megahertz. So this particular signal is having frequency component of 99 megahertz, so it is not allowed by the filter. So what will be the output of high pass filter? Output of high pass filter, which is x2t, and it becomes 1 by 2 cos 2 pi fc plus fm into t. Now in order to obtain the y of t signal, this x2 of t is added with c dash t. So this y of t becomes 1 by 2 cos 2 pi fc plus fm into t, and this c dash t you can write it as sine 2 pi fmt. So this y of t can be written as, I can apply the formula of cos a plus b, so it becomes 1 by 2 cos 2 pi fct into cos 2 pi fmt minus 1 by 2 sine 2 pi fct into sine 2 pi fmt plus sine 2 pi fmt. So I will write it as 1 by 2 cos 2 pi fmt into cos 2 pi fct plus 1 minus 1 by 2 sine 2 pi, sorry, this will be sine 2 pi fct. So it will become sine 2 pi fct. It will also become sine 2 pi fct. So it will become 1 minus 1 by 2 sine 2 pi fmt into sine 2 pi fct. So this yt becomes equal to 1 by 2 cos 2 pi fmt into cos 2 pi fct plus 1 minus 1 by 2 sine 2 pi fmt into sine 2 pi fct. So we know that it becomes the format of a cos 2 pi fct plus b sine 2 pi fct, and the envelope of yt will become under root of a square plus b square. So here we will write it as under root of a square, which is 1 by 2 cos 2 pi fmt square plus 1 minus 1 by 2 sine 2 pi fmt square. So you can write it as 1 by 4 cos square 2 pi fmt plus 1 by 4 sine square 2 pi fmt minus 2ab. So it will become 2 into 1 into 1 by 2 sine 2 pi fmt. So if you will combine this particular component and this component, so it will become 1 by 4. So envelope becomes under root of 1 plus 1 by 4 because it will become cos square theta plus sin square theta minus sine 2 pi fmt. So envelope can be written as 5 by 4 minus sine 2 pi, and this fm will become again 1 megahertz. So you can write it as 10 to the power 60. So this should be the right answer. Let us check the options. So in the C option it is given that it is 5 by 4 minus sine 2 pi into 10 to the power 60. So this must be the correct answer for this particular problem.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is Vishal Gate. Write my name and attach gate to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code Vishalgate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription, cost of the plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay, you can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.